On the 18th of December 2022, the Hawaiian Islands were in the grip of a severe winter storm, which was moving up from the southwest, carrying with it heavy thunderstorms, gusty winds and intense hail. During these kind of conditions, the job of pilots and air traffic controllers quickly becomes very complicated, as loads of aircraft generally will be forced to abandon their normal arrival and departure routes to avoid flying through storm cells, and that's exactly what it was like on this day. On the ground in Maui, two pilots from United Airlines were sitting in a shuttle bus taking them from their hotel towards Kaului Airport, where they were scheduled to operate United Airlines Flight 1722 towards San Francisco. As they looked out through their car windows, they could see the rain pouring down and the palm trees battered by the gusty winds around them. They knew that there would be a challenging start of the flight ahead of them, but as an airline pilot, that kind of comes with the job. Now, both of the pilots were well rested and in a good mood. It was around lunchtime, and except for the departure weather, they were looking forward to a nice flight ahead of them. The aircraft that they were going to fly was a 22-year-old Boeing 777-222. It had no open technical malfunctions recorded, and it was arriving into Maui at the same time as these two pilots were now getting closer to the airport. On board the inbound flight were the 8 cabin crew members who were then going to fly with these pilots back again to San Francisco on their second flight of the day. When the news of this incident hit the media, there were a lot of initial speculation about whether or not these pilots were part of a wave of inexperienced new hires and therefore a sign of a potentially unsafe trend within the industry caused by the looming pilot case. The captain, who was 55 years old, had over 19,600 hours of total time, and 5,000 of those had been flown on the Boeing 777. Only 300 of those 777 hours had actually been flown as a captain. The final report doesn't clearly say this, but there is a possibility that the captain might have operated on the Airbus A320 between his co-pilot 777 experience and when he returned to it as a captain. That's often how it's done on the major airlines. If that was the case, you just have to use your side stick to point the nose of the aircraft where you want the aircraft to go, and then the aircraft will auto-trim and basically do what it's told to do. But in the 777, you would have to remember to trim the aircraft yourself and react to whatever forces that the underslung engines and the flaps might cause, just like in any other Boeing aircraft. The co-pilot was also quite experienced, with around 5,300 hours of total time, but he was very new on this particular type, with only 120 hours on it. This likely also meant that he was relatively new in the company. Again, the final report didn't specify this, but such a relative inexperience could potentially be the reason for one of the misunderstandings that will lay the foundation to what's about to happen. As they were sitting in the shuttle bus, the pilots thought that they should use the time and started going through their pre-flight briefing. The captain got into contact with a United Airlines dispatcher who advised them about the very challenging weather around the Hawaiian Islands. Together, they then decided on a new, alternate routing that should bring them away from the most severe parts of the storm. The two pilots also looked at the technical status of the aircraft, which was fine, and the nose times, but everything looked reasonably okay. The departure weather was definitely the biggest problem. When they arrived at the airport, the first officer bought a sandwich and a cup of coffee before they proceeded straight to the gate where the aircraft had just arrived. As they got on board and introduced themselves to the crew, the purser, which is the head cabin crew, started by telling them about the very turbulent arrival that they had just flown through, and this just further highlighted the complicated weather that they had in front of them. The captain thanked the purser for the update and then briefed the crew that he wanted them to stay seated after departure to make sure that no one got hurt from the expected turbulence. The purser agreed, and after this, the captain, who was going to be pilot flying for the leg, went into the cockpit and started preparing for the departure, whilst the first officer went outside to do the walk around, and by the sound of it, it definitely sounds like it was first officer weather for walk around. As he was doing the pre-flight inspection, the first officer received a text message from a friend telling him about an incident of severe turbulence that had just happened to a Hawaiian Airlines aircraft arriving into Maui. The first officer showed that text message to the captain later when he entered the cockpit, and they both agreed that they would have to observe extreme caution during the departure. They continued to prepare the aircraft and complete the briefings, whilst the crew boarded the 271 passengers who were scheduled for the flight. When it came time for the performance calculations, the first officer tried to take the 80s, but it didn't work for some reason, so he had to call the tower up to get that info instead. The tower advised them that the winds were reasonably light at the moment from a southerly direction at around 10 knots, and at the moment they were using runway 20 for departure. The first officer, who had extensive previous experience flying in between the Hawaiian Islands, commented on the fact that it was very unusual that runway 20 was being used, but thought that it likely had to do with the complicated weather affecting arrivals. In any case, because the winds were reasonably light, their performance software, Sabre, suggested that flaps 20 and a D-rated thrust should be used for departure. D-rated thrust means that the engines will not be producing full thrust when takeoff thrust is set. Instead, they will only produce as much as needed to perform a safe takeoff, of course with all applicable margins accounted for, and we pilots decide on how much D-rates to use depending on the outside circumstances. The only reasons we would use full thrust is in case takeoff performance actually requires it, or if there are environmental reasons for doing it, like very strong crosswinds for example, or a wind shear warning. Like I mentioned before, the pilots had decided to use flaps 20 for departure, and this is significant as flaps 15 is by far the most common takeoff setting on the Boeing 777-200. Now, a curiosity with the 777 is that if flaps 20 is being used for takeoff, when the flap retraction is initiated, the pilots won't go from flaps 20 to 15, which is the next flap step, but instead directly to flaps 5 and just skip flap 15. So this is what the captain was planning to do, as he had done throughout his 777 career so far. Another thing that we need to discuss here is the way that the different flap settings and their respective maximum speeds are shown on the pilot's primary flight displays. The minimum flap speeds are generally shown as a little flap bug with an associated number on it, situated on the speed tape, which is on the left side of the primary flight display. Now, in the case of a flaps 20 departure, the flap 20 bug might not be shown, but when the nose is lowered to accelerate, a positive speed trend is observed and the speed is high enough to start retracting the flaps, the pilot flying will call for flaps 5, and the pilot monitoring will then first verify that the speed is safe and then select flaps 5. This procedure will then continue as the speed keeps accelerating, so that when the flaps 5 bug is passed, flaps 1 will be selected, and so on until the flaps are fully retracted. Now, since the flaps and slat increases the wing's overall area and curvature quite a bit, they're obviously subject to certain maximum speed limitations. The more flaps you have selected, the lower that maximum speed is, and that's shown on the speed tape as an alternating black and red barber's pole. If we would for whatever reason exceed this maximum speed for a given flap setting, it could cause damage to the flap mechanism, and we therefore need to report any flap overspeed to engineering so that a proper maintenance check can be performed. Because of this, we always monitor the speed tape as we're accelerating to make sure that the barber's poles keeps moving up as we retract the flaps, and if they don't, it could be a first indication of a flap problem. Like when the pilots were fully ready, they contacted Maui Tower to ask for pushback and startup clearance. This was received, and during the pushback the pilots could hear that the wind was starting to vary between 030 degrees and 190 degrees, and also that there were low-level wind shear warnings in effect, and that the runway in use had now changed from runway 20 to 02. Like I mentioned earlier, wind shear, which is when the wind suddenly changes directions or intensity, is one of the reasons that precludes the use of D-rated takeoff thrust. And that's because if the aircraft finds itself in a wind shear, it will need all of the engine thrust margins that it can possibly get. So the pilots finished their pushback and engine start, and then went into their FMC and changed over all of their planning to the new runway. They again selected flaps 20 as the departure flap setting, but this time they would use full thrust instead. They also manually re-entered the V1, rotation and V2 speeds, but they used the speeds associated with the D-rated takeoff, as that was both allowed according to the United SOP and would be more conservative. One thing to remember when doing a full thrust takeoff is that if there is no wind shear to deal with, the aircraft will accelerate and climb quicker than it normally does, since it has a lot of excess thrust. As they were now taxiing out, the pilots found themselves in a queue of departing aircraft, and they used that time to carefully brief what actions they would take in case of a predictive wind shear warning during the takeoff roll, or an actual wind shear once they got airborne. Eventually, they reached the holding point and were cleared to line up and wait runway 02 behind the departing Airbus A321. They did so, and since they now had to wait a few minutes to get enough separation to the preceding aircraft, they had plenty of time to study the weather radar picture on their navigation display and make sure that there were no storm cells in their immediate departure direction. The captain had weather radar selected on his navigation display, and the first officer had terrain, which is a pretty standard setting for a departure like this. At time 14:49, United Airlines flight 1722 was cleared for takeoff runway 02. The surface wind was then reported as 140 degrees at 10 knots in moderate rain, so they switched on their windshield wipers to high. The captain moved the thrust levers forward to first stabilize the engines and then push toga, which caused the outer throttle to set full takeoff thrust. The aircraft accelerated rapidly down the runway due to the higher than normal thrust setting, but the rotation was completely normal, followed by the gear being retracted and an initial climb attitude of around 12 to 15 degrees. The aircraft gained altitude fast and soon began experiencing moderate turbulence, which caused the speed to start fluctuating. The captain was flying manually at this point and likely had to work quite hard while still trying to judge the departure ahead to make sure that there were no storm cells popping up. When the aircraft passed 1,000 feet, the autothrottle reduced the thrust from takeoff thrust towards climb thrust, and this also coincided with the minimum flap retraction altitude. This meant that the captain now lowered the nose slightly to start accelerating the aircraft and get the flaps retracted, and now things will start to happen very fast. The speed was accelerating. The captain called for flaps 5 to be selected. He then looked down onto his speed tape and saw that the maximum speed for his current flap setting was fast approaching. The first officer thought that he had heard the captain call for flaps 15, and since that was the next flap step, he didn't think about questioning that at all. Remember, he only had around 120 hours on the type, so he might not have thought that this was an odd command to ask for. At the same time as the captain called for this new flap setting, the tower controller also called them up and asked them to switch over to Honolulu control. The first officer responded to this call, switched over to the departure frequency and then selected flaps 15 as he called the new controller up. He was immediately cleared to continue the climb to 16,000 feet, and the controller also advised him that there were extreme precipitation in all quadrants and that they were clear to avoid weather at their own discretion. The first officer read back this message and then proceeded to set 16,000 feet in the mode control panel and then select weather radar on his navigation display as well. Whilst this was going on, the captain was still looking at his primary flight display. He was expecting the barber's poles to start moving up to the flaps 5 maximum speed, but as he was still accelerating, he got the feeling that the barber's poles were actually moving in the opposite direction. Now in reality, the maximum speed did move up a bit, but only about 20 knots, not the 40 knots that he was expecting. He saw the speed increasing rapidly and understood that this would likely lead into a flap overspeed. To try and minimize that, he decided to override the autothrottle and pull back on the thrust slightly. Now, this caused the huge underslung engines to decelerate slightly and therefore create a slight downward pitch momentum, which caused the aircraft to pitch forward a bit, but it was still climbing at this point. Remember, on a Boeing, you still need to trim the aircraft and look after it very carefully, especially during configuration changes. The captain's attention now turned to what was happening to the flaps. In his mind, the flaps should have been moving to flaps 5, and since that was not happening, he was now anticipating some kind of flap malfunction and started looking at the ACAS to see if there was any emergency procedure that needed to be done. And since there was nothing there and no chimes had been heard, he called flaps 5 again, twice, and then looked at the first officer to verify that he indeed was selecting flaps 5. But as this caused him to divert his attention away from his primary flight display for around 10 seconds to try and figure this out, the captain had not noticed that the downward pitch motion of the nose had continued, and it had now moved to around 0 degrees pitch and was still moving. Now the first officer had noticed this and thought it was a bit strange that the captain was pitching forward in response to a high speed event, but because of the moderate turbulence, he was unsure if the captain was actually reacting to some kind of handling difficulties or a wind shear, or that they might even have some kind of instrumentation problem. Remember, all of this happened in a matter of only a few seconds. Now, he did ask the captain about the pitch, but received no immediate response. Instead, the captain asked for flaps 1, likely still concerned and concentrated on the impending flap overspeed condition. But since the aircraft was accelerating here and the captain was looking away from his instruments, that acceleration might have been momentarily interpreted by his inner ear as a slight pitch up. You see, our balance organs cannot distinguish between an acceleration and a pitch up, since they both affect the little hairs in our inner ears in exactly the same way. If that was the case, well, then he might have been momentarily reacting to that perceived pitch up without even thinking of it. The aircraft had now reached a maximum altitude of around 2,000 feet before it now started diving down towards the water below. The first GPWS warning announced was, according to the first officer, a "don't sink" command, quickly followed by "sink rate" and "pull up." At this stage, the first officer sensed a movement in the clouds out of his peripheral vision, looked up and saw that the sea was now coming towards them as they broke through the clouds. This was when he truly realized what a dangerous position they were now in. The aircraft was now pitching down more than 10 degrees and it was still getting worse. The captain called for flaps up, and at the same time the first officer and the GPWS were calling pull up together in unison. The maximum vertical speed was recorded as 8,536 feet per minute at an altitude of 1,386 feet, and the lowest pitch was around minus 15 degrees. The captain now immediately responded by starting to pull up on his control wheel, whilst the GPWS continued calling out "too low terrain." This pull caused a vertical G-loading of around 2.66 G, and finally, as the aircraft reached its lowest point of 748 feet over the sea, the giant 777 now finally started moving its nose towards the sky again. The captain initially reduced the thrust slightly, again probably to avoid that flap overspeed that they still had, but soon added maximum thrust in accordance with their controlled flight into terrain, CFIT escape maneuver. The aircraft now pitched up to 23 degrees nose up and reached a maximum climb speed of 8,680 feet per minute before the captain returned the nose towards the flight directors, got the aircraft back into trim, and then finally engaged the autopilot. From the time that the captain looked away from his primary flight display until they were in the most critical part of this incident, it had only taken about 10 seconds. The crew continued climbing towards their cruise altitude and had to continue to avoid storm cells and moderate turbulence for the rest of the climb. Once they had leveled off, the captain contacted the purser to check on the status of both the passengers and the crew, and luckily they had all been seated with their seatbelt fastened during this ordeal, and they had actually been expecting some quite severe turbulence, so they were all fine. And since there was no indication of anything wrong with the aircraft, the crew elected to continue their flight towards San Francisco. During the cruise, the pilots debriefed what had happened and decided to file one report each when they arrived to the base, which was the correct thing to do. They then did an approach and landed uneventfully in San Francisco, and of course the flap exceedance had already been reported by the aircraft itself, so they were met by engineering at their arrival to check on the flaps. Even though the pilots and both of the cockpit voice and the flight data recorder had been overwritten, so this report is based on the interviews with the pilots and ADS-B data, as well as whatever they could retrieve from the aircraft quick access recorder. The report finally said that the incident was caused by a miscommunication between the pilots, which led to a failure to manage the aircraft's vertical flight path, airspeed and pitch attitude. The outcome of the investigation led to United Airlines modifying one of their pilot training modules, as well as releasing an intra-company awareness campaign describing what had happened and what could be learned from it.